All right. Hello, everyone, and welcome to this Bitbar webinar. Our topic today is how to efficiently automate testing of React Native apps. And my name is Ville-Veikko Helppi, and we'll be talking a bit about React Native, what it basically is for Android and iOS, and how you can actually use today's test automation frameworks to test your React and React Native apps on these platforms. Before we start, if you have any questions during this session, please use the right hand side box, and there's a questions box where you can actually enter any of the questions. And basically at the end of this webinar, so I'll be dedicating 15 minutes or so for the questions if you have any, or if you want to talk about or ask any questions about hands-on things, how actually certain things with React Native can be tested, or if how some framework actually uses for specific use case. So for our agenda today is basically that we'll start with the React and React Native stuff first, look at it a bit from architectural and also from the infrastructural point of view, and what basically testing and test automation means in this context. Majority of my presentation today will be focusing and actually is dedicated for these different frameworks. So I'm covering the most used frameworks for the for Android and iOS here, and what different flavors do they have for React Native apps, and what sort of things you should know from the test automation point of view if you use these frameworks. We're also going to talk a bit about the programming languages. So what sort of things are there, for example, with certain frameworks? What do you need to know from the test automation point of view? And also talking a bit about tools, methods, and different available frameworks around these test automation frameworks. And like I said, it's going to be 15 minutes at the end dedicated entirely for the questions. And if you have any questions during at any point or any comments you want to make, please use this right-hand side box and enter your questions there. And I'll be definitely looking all of those and as many of those at the end of this presentation. So, of course, React and React Native. So I believe it all got started with React roughly more than 4 years ago when Facebook introduced its framework to web developers. There was no question it was bound to be popular, not just because it was authored and developed by Facebook, but because of what sort of capabilities it provided. And there was fundamentally a lot of things that actually changed the way basically developers build their apps or web developers build their stuff. So, of course, this sort of concept or this type of learn once, write anywhere type of cross-platform framework wasn't new. There was a lot of Java libraries, JavaScript libraries that basically did the similar things, Sencha, PhoneCab, and so on. A bunch of others. But, there was something really much better about React, and web developers seem to love it. So, how basically it break down the application UI into discrete components, and especially from the UI standpoint. React Native basically doesn't use the DOM, as we know, for rendering, basically, but instead it renders the native UI view. So this means that when you're using a native components with these provided or these platforms operating systems, these are basically part of your UI, what you see with your application. And this sort of product creation flow, when you replace the DOM API with more or better imperative API, that gives developers more ways to build these kind of cohesive and simplified levels of abstractions. Also with the React, there was interesting component, this JSX JavaScript extension, and it looks a bit funny first when you look at it, but it all made sense when you started playing a bit more with React. After the React, of course, there was React Native, again, authored, and everything was outsourced, open sourced by Facebook. So the key thing I think with the React Native was that how it actually brings this kind of React programming model to mobile apps, also to development, but more and more for testing as well. So it's not really like a cross-platform tool or framework where you build once and you just duplicate to the other platform. But it kind of makes it easy to build that same experience, same user experience and UI for the basically the new platform. And typically we've seen Android and iOS apps where React Native implementation have been tested on our public cloud especially. So I think one of the things that actually made React Native so powerful, and it was pretty easy to learn and also write those on a new platform. So switching from the Android to iOS and back forth, everything worked the same way in a conceptual level. Yeah, of course what's the biggest difference? I think the comparing real native apps versus this sort of React Native application was that instead of HTML elements, they are now relying on this kind of inside embedded JavaScript core inside those applications, and which actually gets the all those platform specific UI components from the actual operating system. There could be something else also for React Native. So I mean, alternative workarounds, or there could be something, you can still build the application different way. So for example, very common way is to use these web views inside the mobile apps. And when this implementation method is in use, basically the rendering is done with the web techniques and web technology, all those parts. And that of course makes it different from the native. Also, they could have ported React to native platform where it would run against these actual components. But of course, we know how operating systems evolve. They constantly provide new stuff and new APIs. There would be lots of things from the support standpoint to think about, and basically support these sort of platforms would be probably a nightmare. And of course, when you do this kind of thing, recompilation, or you would build anything again, or just change something with the code, you would basically need to recompile that. Talking about this, there's a project called Component Kit, which is also open sourced, and that basically is very similar to this kind of use case. The third way could be basically something like injecting JavaScript to call native API. That's not necessarily that straightforward and easy to do. So basically, considering all these alternative workarounds, so there was obvious need for React Native type of implementation, and how it could actually help native app developers to build new experiences and new apps, and also make visually rich, UI rich components inside those applications. So what are today's challenges with the React Native apps? Of course, we talk about quite a lot of UI components, so that really hasn't changed. We still have a lot of devices for Android, different screen sizes, different resolutions, even orientation tend to work differently based on different operating system version, and also some of the devices. Same thing with the Apple. So when you build an iOS application, you still might need to build different app for iOS, iPad and iPhone. But in some of the implementation, like with React, you probably don't need to do that. We've done a lot of research on this field, especially how people have executed their React Native apps on our public cloud. I also tried to find some study on how many of applications today basically introduced in the app markets are using React Native as a basis, but there wasn't really any up-to-date or any good data about this. What we know, of course, that there are a few very, very popular apps actually that have been built with React Native. But what are these challenges? So, of course, screen resolution appears to be the number one kind of reason why people don't or are hesitant to go to the React Native. We've talked about quite a lot about this. The resolution itself doesn't cause that fragmentation, but it's sometimes, and in many of use cases, it's more about the orientation, what's actually in the device. So meaning chipset, memory, all the combination of that. So when you have a smooth, slick probably a new high-end device, you might still get the better performance as the older ones. Even the display resolution, display specs are pretty much the same what it would be with some mid-range or lower-end device. So where test automation can actually help React Native apps. So let's look at this kind of diagram. So we know that majority of people building their apps are using, of course, with the iOS they use Xcode. With Android, it's Android Studio, and they have a different languages. There's a lot of differences now. Why you think why should I use cross-platform test automation framework when we have a different languages used with the different platforms? But it actually makes sense because React Native is built with the embedded or use that JavaScript library, and there are certain things with core libraries and that those platform UI components. There's certain style and layouts, and of course those platform APIs that are coming from these operating systems, and those basically contain the native components. And between this kind of middleware layer and application code, there's the bridge, which actually makes it smooth to push all these components to the actual application. And then you combine it as a React Native JS and using that with JavaScript core and eventually build it as a native application. So going back to the original question, what are the areas of test automation with React Native apps you should think about? First of all, of course, there's devices. So it's always recommended to use real mobile devices to get tests done, even whatever you are building strictly native or React Native or any type of application on the mobile. So use of real devices is definitely one of those top requirements. I would say the test automation frameworks and how they come and play with these two platforms. Even they have language. What you use to build that application are different. You still can execute and implement your tests and scripts using certain framework. There's a bunch of great frameworks that actually work for platform-specific use cases, but also these cross-platform frameworks that actually can be used across both platforms. Third thing is, of course, the unit testing. And unit testing in this kind of context could be as basic as testing JavaScript objects or methods on the component level. And other part of that, each component, for example, could be tested either visually or functionally. And what React Native actually provides is this React test utils that provides a pretty simplistic framework for testing React components. But it makes it easy actually to test React components and basically use it as part of any of your framework that you end up choosing or using. And we've been using Jest, of course. That's one of the standard frameworks with the React Native, and that seems to be pretty painless for us as well. We haven't actually seen any major things. If you build an application that needs to get robust level and you want to do unit tests or some sort of component level tests, Jasmine is a great option for that. Next would be, of course, some sort of integration testing, and this can be seen actually two different ways. So it's either a group of these unit tests that are combined as an entity, or it can be somewhat a smoke test where you test your latest changes, how they actually work on certain platform. So, for example, like integration test, in the context of mobile devices, could mean that the implementation is getting tested on those physical devices, but also like grouped all those unit tests you might have implemented for your application. Next is functional UI testing, and that's where we are actually heading. So application code, of course, contains a lot of UI logic, and it's more sophisticated than any of these unit and integration test levels. It's pretty much like a type of black box testing, and it focuses on these user requirements, interactions that users are doing on application. But it also covers some part of this underlying software. So, for example, what happens with the certain activities, what happens with the backend when you click certain button, or you just implement or do a gesture there, or do anything with the application basically, and how that comes across with the whole platform and whole thing. And finally, there's of course regression tests. So each and every time you do a change and you actually build your IPA or APK again, it's always recommended to test that on a real device. So it kind of loops back to the first one. So use of real devices at stages where you have actually built the latest version of the IPA or APK. There's also some different levels of testing for React Native. So many of UI components that are used with these native apps, they can be either used, or the path how they get tested can be done with the unit testing methods. So React.js, JavaScript, hardcore, or you can also use Selenium in certain extent in a browser if you test browser. Use browser and test how that implementation works. Selenium is a choice for that as well. But when going to the native side of things, there's basically platform-specific frameworks and some cross-platform specific frameworks that you can actually use to test your application. And not only these, but of course, there's, as mentioned, that React test utils in use. So those provide some useful unit testing methods. They don't necessarily thoroughly cover the application logic, so it's better to recommend some functional test automation frameworks. And even these unit tests can be done at the component level. The functional tests still provide better capabilities to test larger entities, the UI, of course, but also how these UI components can be isolated. How they can be actually interact with, those sort of things are typically none or not really the scope for unit tests. So in this context, unit tests are useful and they provide some basic good stuff for testing purposes. But the earlier you adopt any of these functional UI testing frameworks, you definitely get more results sooner and start seeing how those tests will actually work with the app, and what sort of things you should really fix with the app before you consider publishing it. Before we move to these functional UI test frameworks, I wanted to mention about the unit testing. So by default, React Native provides this Jest testing and tests available. It's of course for unit testing, but it also works pretty well for both Android and iOS. And the actually Facebook hasn't improved quite a lot what kind of test they have included in this test pattern. So it's not really perfect at the moment, but according to them, more unit testing capabilities will be introduced later in React Native, and users, of course, they can build their own stuff at the moment. So we of course looking to see how the and what sort of out of the box unit tests are coming with React Native. Here's one code example. Actually, it's a pretty simple Jasmine Jest example. So Jest basically uses the Jasmine behavior driven framework as a basis for getting these JavaScript codes tests. And every test case basically starts with this describe function call. It's basically similar how JUnit uses test case class. And the next one is this describe. So basically, describe function takes a couple of parameters, like what's the description of it and what's the title of the test case. And there's next one is it. So what basically it function does is includes all these test steps, and it's pretty similar to JUnit, as it provides the series of expect functions as well at the end. So like what you should expect from that test to be get out. Also, there's some integration tests as part of the React Native. So two components primarily used are this RC test runner, RC test module. At the moment, these integration tests highlighted in React Native community are unfortunately available only for iOS. I haven't at least seen any Android specific integration tests yet. And basically all this communication goes through the bridge, and so it requires both native and JavaScript components to be there. There's a couple of ways actually to run integration tests and extend it to the Android and iOS. So good alternative is Mocha. That's a very feature-rich JavaScript test framework that runs on Node.js. And the Mocha also provides some BDD, behavior-driven development, and test-driven development, TDD, and QUnit interfaces for testing. So if you think about doing integration testing on React Native apps, there is something available. Unfortunately, iOS only at the moment, but hopefully something soon for Android as well. Okay, let's move to these functional UI test frameworks. So we're talking basically, when we say cross-platform frameworks, we're talking about Appium and Calabash. If you're familiar with these frameworks, they basically provide a very sophisticated and excellent way to build a test case for your application that runs similar on Android and iOS. And that, of course, streamlines the app development process and also maximizes the testing coverage, as you can use these sort of, build once or create once and use it on several platforms. So that's great. The best choice, of course, if your application is running on these both platforms, is to use a framework that supports multiple platforms like these Android and iOS. When we look at the platform-specific frameworks, there's a couple of them used today with React Native. What we've seen here at Bitbar, and especially used with our public cloud on Android, I think the most common, most popular are UI Automator and Espresso, and on iOS side, XCTest and Earl Grey. Earl Grey's interesting framework actually has come, I think it was open sourced earlier this year, or very late at the beginning of last year, and it has been roughly a year here. And we've seen it actually growing slowly, but there is some serious usage of it, especially for the certain types of apps. This kind of summarizes what we've been talking about, the frameworks where they are supported. So XCTest, XCUI test, it's iOS framework. It supports in certain extent mobile web. You have to embed that stuff into the app. Languages you use, Objective-C, Swift, and it's very tightly coupled with the Xcode, of course, provided by Apple. A couple of other frameworks for Android, like UI Automator, Espresso, are by Google. Of course, targeted for Android only. Both of them are working slightly differently, but they use the language as a Java as a basis. They have some tools. For example, the UI Automator Viewer is a very handy tool, even you use some other framework, or even whatever framework you use. Basically, UI Automator Viewer is a great tool to inspect some of the things, what's actually in the UI components and so on. And then these two frameworks like Appium and Calabash, basically they are built by communities of their own. They work both Android and iOS pretty well. Appium, of course, because it comes from the Selenium point of view or the foundation, it basically provides also mobile web testing. Calabash doesn't. There's also some language differences. I'll be talking a bit more about both of these frameworks in a minute. But Appium especially, it scales really well with different programming languages, and you can pretty much use any language what you actually have been using for your development or that you are familiar with. So that's especially handy for these kind of use cases. So let's focus on these two frameworks. And Basically, first Appium. So Appium is an open source test automation framework with the inspection tool, what's called Appium Inspector. And it really works well for native, hybrid, and mobile web apps, both on Android and iOS. Despite that, there has been some turbulence lately with the iOS 10. I would still say that Appium has been definitely one of the hottest frameworks used by the community, entire test automation community. The thing, of course, is that it's very easy to use. It actually derives its stuff from Selenium WebDriver, so it uses it as a scripting framework, and it has been a standard for a decade or even so longer for browser automation, and it provides libraries for pretty much any languages. When it runs on Android, if you are using some older device that having a older API level, older operating system version, it actually uses Android as a foundation, but it basically uses the UI Automator with the latest ones. On iOS side, it used to use UI automation, and it basically still does if you use Xcode 7 or older. But the latest Xcode 8 actually introduced Apple deprecated the UI automation entirely from the Xcode 8. So now the only option really is if you want to use test automation, is XC test at the moment. I mentioned this, but Appium, it's definitely one of its core benefits that it basically provides support for any programming language. You can really use it with multiple very, very popular languages, and you are not limited to any of those. So it's very easy to scale and even use it further with some others: Java, Ruby, Python, C#, anything. So that's really fantastic. You don't have to change the language if you are up to snuff, or you want to use certain language. So what basically goes here is of course I mentioned that it's coming from Selenium WebDriver, and like you use Selenium WebDriver for the browser-based testing for desktop web. Basically, Appium provides it the same ways, desired capabilities, all those features for native apps and also the mobile web. And there's a couple of things you might need to know, especially with the running it on simulators. The browsers are working very much differently, if they even work on emulators and simulators with the Appium. So that's one of the reasons as well why you should always try to use the real devices when you actually build a new version or you actually do a regressions on your application. So it's always recommended to use those real devices for your testing, and combine those with probably with your CI environment. That's very trivial and easy with Appium, so easy to combine. If you're using Jenkins, TeamC, Bamboo, any of these popular CI systems, it's basically everything is easy to combine with the Appium and real device testing. Here's an example how you would actually use a React Native based app. So there was a very simplistic application, couple of radio buttons, edit text, and click button or button, and what it basically does. So it would be the same way you would use it for any native app that you would use it with React Native app. So desired capabilities would be configured the same way. Element ID, actions, everything would be identical what it would be with any type of other app that you use Appium with. So basically what happens inside the Appium, when you have the script, there was this example like, there's certain app ID, you want to perform clicks on radio buttons, you want to edit text, you want to find element by OK or whatever name. So Appium starts a test script on a device or emulator, which then creates a server and listens to commands from the main Appium server. It's the same way as the Selenium server, which actually gets the HTTP requests from the client libraries. And how you actually have it different with the iOS. So Selenium WebDriver actually gets a command from Appium script. For example, that click button there, It sends it in the form of JSON via the HTTP request to Appium server. So Appium knows the automation context and sends this command to instruments command server, which then waits for instrument command client to pick it up and execute the with the bootstrap.js. So again, JavaScript. That's in the iOS instrumentation environment. Once the command is executed, the instruments command client sends the message back to the Appium server, which then logs everything what's related in the command in that console. And this kind of cycle keeps it going on the iOS. That's basically how it works on iOS. On Android side, things work pretty much the same way, except the framework that you are using are either Selendroid or UI Automator if you are using some older OS versions. And the on a physical device, actually, that bootstrap.jar file launches a TCP server that gets commands from the TCP client. And this is very much the same way how it actually works with the instrumentation on the iOS side of things. With Appium, there's actually more capabilities, like how you can actually run a test against a device that may reside somewhere else. So there's a lot of services that actually provide devices on the cloud, device farm types of setups. So if you have everything on your local host, you can basically define your desired capabilities. You can define what devices you want to use for test execution, what application it will be used for test session, what testing properties and different characteristics are used. And that's all defined in localhost. You basically set that up with the WebDriver capabilities, desired capabilities, and test case. And then it's basically when you execute that, it starts communicating with, for example, in our case, it's Test4 Cloud's Appium broker that actually gets all these commands and basically dedicates or reserves a device, sets up the Appium server as we discussed, and basically starts executing that test there and basically returns everything back to your local host. So you can pull everything from that test session back to your local machine, like screenshots, logs, video of that test session, basically anything result-wise that what happened on that device run. In this kind of case, you upload the application first to the our premises or our cloud, and you just need to execute that test. So you don't have to upload again the application if there's no changes. If your test only changes, that's the way how you only change the script itself, and then basically execute that further and further. On server-side execution, you basically you don't have to configure that many desired capabilities. You basically set up the URL that you want to use. You basically set up the WebDriver to the certain setup. What for example, that it's going to use the local environment. You upload the application and the tests as a zip file on our Test4 Cloud, and the test script actually gets executed on those devices you can manually select, or you might have some device groups where you want to run that test. So it's very effortless and easy to use. You just manually go and click. And also there's a way to use API to push all these, like the application, but also the test package on our cloud, and test will start instantly on certain devices. And whenever tests are finalized, basically the results are fetched back to the local environment. That's pretty much about Appium. So let's move to the Calabash. Another very popular framework for the cross-platform use. One of major difference between the Appium is that it's human-readable syntax, and tests are pretty much written in English. So you don't have to be a programmer to write a test with Calabash. These tests are basically described in Cucumber, and then they are converted to native in a runtime. Also, Calabash provides lots of different language commands, these controllers that you actually by default, and the new controls can be very quickly implemented in Ruby. So that's the only major difference with the Appium and Calabash, that you basically define and set everything with Ruby on Calabash side of things. This might work slightly different when you have a React Native app and you run it with the Calabash. So especially those custom UI widgets. So what I've seen that there's very often cases where something goes wrong with that controller implementation. So just simply a line of Ruby is wrong or something like that. And basically then, that UI widget doesn't necessarily get identified. That sort of things I've seen with the Calabash running with the React Native apps. Syntax, as mentioned, is pretty easy and it's very easy to understand. It's strictly basic English. There's a couple of things you need to know when you build these. So features, scenarios, steps. Feature is like a description, the highest level description of what you're gonna test. For example, login feature here. Scenario is that you define the case for that. As a valid user, I can log into my app. And then steps, what actually happens in each step when you go inside your app and when that test is executing. So what actually happens on a Calabash? So on Android side of things, there's actually a separated app instrumentation test server that actually gets installed on that device. It basically uses the activity instrumentation test class, and all these tests are executed on the server side. Calabash also provides quite a lot of predefined and custom steps. These are, of course, configurable by yourself as well. You can build your own. And all these library, or whatever you define with Ruby, basically they get converted as a Ruby commands to native method calls. There's certain level also to do tests for web views when you actually have a JavaScript injection to the web view, but there has been issues with the React Native apps. It doesn't always. Again, you have to be very cautious, carefully with what do you do with those custom steps you define, and also controls whatever you define over there. On iOS side of things, it's not that significantly different. It basically installs the HTTP server as an instrumentation package. Basically, it listens these commands from this Calabash server. Tests, again, are executed on the server side, and all these test cases are described in Cucumber. Okay, before we jump into the Q&A, let's quickly look some of the platform-specific frameworks that has been used with React Native and how those have actually worked. So Espresso has been probably one of the latest raising test automation frameworks. One of the things why it's so popular is that it basically provides very fast execution of any tests. There are certain limitations with the Espresso, like you can actually instrument one application and that application context at time. But it's very easy to use, Java, all Java based. So what it actually does, it provides some thin layer on top of your instrumentation. You can actually use this on view, perform, check type of API calls to check what's going on. Why it's actually fast is that Espresso provides really synchronized UI threads, so it waits on the certain calls before it actually does it, if for example, the UI element is not visible on the screen. Unfortunately, there's no way to support web views or anything, so it's all basically missing from that. Taking screenshots, even with React Native, is possible, but you have to implement it by yourself. You actually find this stuff on our blog. We've wrote a couple of instructions how to actually take screenshots, how to actually use Espresso more efficiently, also in a React Native context. So you actually find lots of this information at Bitbar blog. And here's the example. So compared to what it used to be, or what it was with Calabash, what it was with the Appium. So strictly Java code, very simplistic on view, use identify certain element. We use these radio buttons as an example. So with ID, you define the R class there, what's the button, and what do you want to perform there. So for example, a few clicks here, and then you edit something in the text field, and then you click a button that's on the bottom of the example. UI Automator, pretty similar. So that actually provides also lightweight API, and there's similar classes available. So it's not a major difference. For somehow it looks like Google is favoring Espresso at the moment, but UI Automator is still publicly available. It's usable, and it's actually quite widely used. So it's not one of those that are diming anywhere. It actually provides very fast execution as well. And there's this handy tool, UI Automator Viewer. I personally use it for many of other inspections, like, especially if you want to look UI elements, look what's in a native way, you get a lot of information with the UI Automator Viewer. So definitely recommend it. Many of you probably have used it. So it's not only, of course, usable by UI Automator context, but also usable for other frameworks as well. Exitest. It's one of those frameworks that are tightly coupled with the Xcode, and basically Appium now with the iOS 10, Xcode 8 is moving to be in conjunction with the Exitest as well. Exitest, XUI test, they provide really good and easy to use way to build unit tests or basic UI tests for the iOS app. Languages wise, unfortunately, there's only what's provided by the Xcode, so Objective-C and Swift. But all these other frameworks, they use it as a wrapper as well. So anything basically running on the Xcode eventually at the Exitest is on the bottom. So if you are not using Exitest by yourself, I think it's worth of checking what actually it can provide for you. It's one of those frameworks that are extremely tightly coupled with the development environment. It doesn't necessarily give you that sort of feature rich UI capabilities as Appium does because of the WebDriver side of things, but it's very tightly coupled with the framework and basically provides you a solid use case, and of course the tools should work version by version. Okay, finally the Earl Grey. I mentioned that this has been popping up lately as well. It's actually Google's internal UI testing framework. They've used it personally or inside the company for YouTube and Google Calendar, Google Photos, Google Translate, and so on. So what it provides is pretty much like what Espresso provides for Android. So there's UI synchronization and very feature-rich user-like interactions, all clicks, gestures, all kind of interactions you would think user would actually do for the application. And the visibility, of course, before you do interaction. So that's the available. Also, this is open source, so you can actually get a hold of it pretty easily, and you can actually try it and experiment. I've also wrote a few blogs about it. So if you are looking how to get started with Earl Grey, you actually find it in the Bitbar blog. There's available really like how-to material, how to get started, how to do your first test, and what sort of application does it identically or ideally work. There's basically in it 3 APIs for selection, action, assertion. So it's very lightweight. It's not extensive or anyhow difficult to learn, especially if you are savvy with Objective-C. It's easy to use framework, and you quickly can get lots of UI interaction tests done with the Earl Grey. Okay, we went quickly through these frameworks. So as I said, I wanted to dedicate some time for questions, and I can see a lot of them in. So let's see. Let's start going through. Thank you so much for these questions. It's always a pleasure to get the questions. Most typically, we get these questions: what works the best? It really depends on the application. What type of application, and how long have you been using React or React Native? Um, I would say currently Appium is taking a small hit right now. But there should be soon, with the latest version of Appium, full support for the environment. We've scaled everything for the iOS 10, has been running on Tetra Cloud for some time now as experiments, and in our private cloud it has been a longer time. Setting something up in a public cloud where you actually have to support both older Xcodes and Xcode 8 is sometimes challenging, but we found a way, and there's actually a release coming very soon where we tackle that. Let's go through these questions. So first one here is the let's try to find some pattern here with these questions. So there's a lot of questions like how are we, or what are our plans to support certain framework in Tetra Cloud. For example, Xcode test has been used. Xctest has been asked when it's available. It's actually available in private cloud. It should be soon in public as well. Calabash versions, Android, iOS, that works pretty robustly at the moment. Appium 1.6 is out soon as well. So that basically provides the capability to do efficient iOS testing on iOS 10. There's questions about Appium quite a lot. Appium script with JavaScript, Node.js. Yes, of course, Appium is very scalable and it works really well across all different programming languages. So, JavaScript as well, Mocha, Node.js, that sort of foundation actually works pretty well. If you haven't tried out, I think we actually wrote a blog about that as well, where we provide really step-by-step instructions how to get started with Mocha and JavaScript. I think it was in Appium tips and tricks number. I don't remember right now. There's a question like, how do you identify React Native elements in Appium? So basically, that of course goes through the JavaScript. Everything as they are native components, you don't actually have a problem. We've also used image recognition for some trickier cases, especially when you have some UI elements that scale or they are not necessarily always visible on the screen. So image recognition is a really, really great way to actually get the UI testing done. Even with the mobile games, image recognition is definitely the hottest practice there. It's getting used. Let's see what else. We have a lot of other questions. Platforms, Android-wise, Nougat 7.1.1. We haven't seen any major issues with it, but there has been, some certain types of older applications that especially were built for Marshmallow originally. Are failing on some tests because of the new APIs introduced with Nougat, and the this material design has changed some UIs and how they used. But actually, it's pretty trivial rebuild it, the test package, especially if you are using Espresso, and that should be all required. On iOS side of things, Xcode 10 Xcode 8. We support it. It's part of the whenever we have an iOS 10 device. So there's of course Xcode 8 set up, and that's supported. So you don't have to look further. Especially in the private cloud, it's available. You can talk to our folks. They can enable you some experiments on that. What should we? There's probably like 40 questions here, really good questions. Thank you so much for sending. I'm trying to find some patterns. There's questions also about the Calabash, like, how do you what? Yeah, so I mentioned about the the Ruby and those controllers and setting up certain custom UI widgets, especially that has worked slightly flaky with the React Native apps. So you have to really be careful when you build that or set it up. There's a good advice would be that do a smoke test instantly after you build that script, and do a smoke test, see how that works, and where it fails. The logs give you everything where actually the failure is happening and why it's failing. So that's the only good advice that I can think of right now. There's also questions about the image recognition, how to get started. You can actually find it in the blogs as well. If you just search for mobile game testing on Google, you find how image recognition is used, how to get started, and we have new examples available at GitHub. So they work also for the latest Nougat and iOS 10. So yeah, the image recognition wise, I try to go through these questions. So image recognition, there's one comment: image recognition is very unstable way for UI automation. That's true. Now, especially when there's a new Xcode and UI automation is pretty much gone. So I definitely recommend using image recognition. If your app, or especially with the games, but if your app is graphics intensive, if there's anything you can identify UI element wise, certain buttons are always there, or certain things, how you want to kind of drive that execution, I definitely advocate the use of image recognition. It's very clean and easy to implement, and it works the same way across the devices. So you really get the kind of, from the user standpoint, the same test experience, like it would be a real user seeing that button. They would click it, they would interact with the UI. That it of course depends what sort of app you have, especially games. It works really well. Apps where some React Native apps, or many of React Native apps, have changing graphics content around the UI elements. So in those kind of cases, it's not always usable, but you can still identify like certain buttons, or you can actually have multiple content there. Like if any of these is shown, this means that this screen is visible and clickable, interactionable. Node.js, yeah, Mocha and Node.js can be executed on the server-side Appium. That there was a question: can you script Appium with Node.js? How do you basically use it? So that requires the server-side execution with Test Cloud. I think it could work also from the client, but we build basically infrastructure so that on server side everything works. You just zip everything all the test assets in a zip file, and you upload the application, and you upload the test package and select devices, and that's all required. That was a great question. Like, what's your verdict on React Native in general? I think it has a lot of potential. Unfortunately, I was trying to look some figures. If any of you actually find some numbers or figures how widely it's used, so it would be great to share with everybody. I've seen a lot of React Native apps recently, past 3 months getting tested, and from my experience, I think it's pretty robust experience from the cloud device execution point of view. So they seem to work really well. Um, any OS versions, those sort of limitations are pretty minimalistic. You don't have to customize it across all different OS versions and so on. That's my personal impression of it. Probably something is always, you always have when a new version comes out, you have a issue that lots of problems are occurring with that latest OS version. But that's easily getting tackled by Google and Apple. They do release these minor versions pretty often after the major release. So they tackle most of the challenges typically are related to these OS platforms. Couple of questions about Kirkin. I found Kirkin question here as well. Yeah, I mean, with the Calabash, if you're not familiar with Kirkin, it's in a Calabash, actually, the test comprises all the features, scenarios, and steps, like in Kirkin as well. And the recommended flow, of course, always is to complete the highest level description first when you build a Calabash script, like the first features, followed by scenarios, and then those actual steps. What happens in this step? There's a couple of basic questions about Calabash, like what are those keywords? So yes, Calabash has a keywords like given, then, when, and some others that are actually describing the steps, and you can actually find those those keywords in those controllers in Ruby files, what they actually mean. And what else? There's one question about Earl Grey. So Earl Grey is similar, yes. So question is that is it similar to like espresso? Yes. So all the Earl Grey tests basically automatically wait for the event. So is it animation, network request, UI element to show up, or anything? So before they try to interact with the UI. So if the UI element is not visible on a screen, the Earl Grey just sits there and basically does nothing, like espresso. So it's identical in that way. They're both built by Google, so I think they think they find a right way to do the UI testing with the espresso, and they build the Earl Grey the same way. So how do you actually? The question is, how do you use Earl Grey? The second question here popping up. There's Grey accessibility ID and Grey accessibility label, for example, that you can use to identify UI elements on the screen. What's basically with the espresso is those crest matchers. Okay. Unfortunately, there's probably questions I didn't notice. There's a lot of questions. I didn't notice all of them. If you want to get in touch personally, please fire me an email. I'll be happy to help and see if you, especially if you have runs on our public cloud or private cloud or anything that I can see the test script and the what happened if there's issues. There's also a lot of comments. I hope some of you actually participated the live Q&A session we hosted last week. We are planning to do another one. The first one was really successful. We got a lot of positive feedback about it, and we want to give you another session probably early January, so that please stay tuned. And especially if you have any questions, you want to fire me an email. I'll be happy to help. And if you want to ask something more generic you think would benefit the whole ecosystem, other fellows, tester fellows out there, you can do it through the live Q&A session as well. We'll try to tackle as many and cover as many topics as possible in those sessions. Okay, thank you so much. It was great to see lots of attendees on this session, and looking forward to see you again. And like I said, if you have any questions, visit bitbar.com for any information. There's lots of great content on blogs and the documentation as well, where we actually keep providing more and more new information, what's going on in the industry, and how you should, what sort of things you should know about test automation and testing when doing this. So stay hungry and happy testing, folks. Thank you.